Hey guys, welcome to day 7. Today we're going to talk about solving multi-step equations. So first we're going to start by going over the warm-up. If you're listening to this online, you can print out or look at the warm-up and do the warm-up online paper, but we're going to go over it right now. So we came in and we referred back to day 6 where we learned about properties, and the first question says to name the property. So looking at 6a in a list of properties, you can see that if you have 7 equals 7, for example, that would be an example of the reflexive property. So it's reflexive, and that's a new property this year. Okay, if you look at number 2, it says if y plus 2 equals 10, then 10 equals y plus 2. Notice we have an if and a then statement. And if you took this and folded it in half of each other, okay, this would be symmetric. So this is actually an example of the symmetric property. And that's also a new property this year. Okay, so y plus 2 equals 10, then 10 equals y plus 2. It just means we can take what's on one side of the equation sign and flip it with the other side of the equation sign, the equal sign rather. All right, number 3 in the warm-up is going back in time and solving a one-step equation. Okay, we're trying to get x by itself, okay, isolate the variable. And we learned last year to get the variable by itself, you were going to do the inverse operation. So negative 5 times x, the inverse of multiplying would be division. So we're going to divide that by negative 5. We also learned the golden rule of algebra. Whatever we do to one side of the equation, we have to do to the other. All right, so negative 5 divided by negative 5 is actually just going to be equal to x. So they cancel out. And 25 divided by negative 5 is going to be 5. So our answer is x is equal to 5. All right, looking at the next one, and you can always take that and plug it back in, do your check step. So we have negative 5 times 5. Does that equal negative 25? Yes, it does. All right, so we know it works. All right, we're going to get more complicated solving these equations today. But taking that one-step equation and now doing what's called a two-step equation, which you should have done last year as well, we learned that to isolate the variable, we need to start by moving the constant, which is a negative 4, to the other side of the equation. And we did this. If this is minus 4, we're going to do the inverse operation, which means we're going to add 4. And we're going to remember our golden rule of algebra. Whatever we do to one side of the equation, we have to do to the other. So negative 4 plus 4 would cancel out, and we would be left with our 2x. And then a negative 12 plus 4 would be equal to negative 8. And then to get x by itself, here we're multiplying, so we're going to do the inverse operation, which is division. And our final answer would be x is equal to negative 4, because negative 8 divided by 2 is negative 4. Okay, so that's going to lead us into our notes for today. So we actually went over the key for the properties last class as well. And then we got to our notes. So let me just shift this a little bit so that we can see the notes a little bit better here. All right, oops, I'm going to make that a little bit bigger. Come on, that's not cooperating. Let me see. Can't get it. Well, I'll do it here. All right, so solving multi-step equations, we want to use the following acronym as a checklist when solving equations. Okay, this is actually 7A here. Okay, so this is 7A. The notes were off a little bit. So this is 7A. You should be on your notes. Okay. All right, so D stands for, the first thing we're going to look to see if we're distributing. So we might have to distribute. The C stands for combine like terms. The M stands for moving the variable, and that will make sense when we start to do some examples. The A means you're going to add or subtract the constant. Okay, and then the M stands for we're going to either multiply or divide by the coefficient. All right, so we're going to use this acronym. You're going to see me write DC MAM. It's going to help me think of my checklist, my order when I'm solving equations. We're also going to remember the golden rule of algebra. Whatever we do to one side of the equation, we must do to the other. So it's like keeping that seesaw kind of balanced. Okay? All right, so looking at our first example we have here. Okay, let's get this in here. All right, there we go. All right. Okay, first example. So I'm going to start out and I'm going to make my little checklist. I've got DC MAM. Well, I'm looking at my first example and I can't distribute anything. I don't see any parentheses. The C stands for combine like terms. Now this is really important. You're only going to combine like terms on either side of the equal sign. You're never going to cross the equal sign when you combine like terms. So see how we have the 10x and we have the 8x? We're not going to combine them because they're on two different sides of the equal sign. Okay, so we can't distribute anything. We can't combine like terms, but what we can do is move the variable. Okay, if you notice we have two x's, all right, our whole goal is to get x by itself, so we're actually going to combine those x's, but how we're going to do it is with a move. Because we're moving across the equal sign, we're going to look at the right side and we're going to subtract 8x, because 8x minus 8x is 0. That would cancel out. All right, so we would get it to be 0 on the right side, but whatever we do on one side of the equation, we have to do it to the other. So we're going to subtract 8x from both sides. We get 2x plus 18 is equal to 4. Okay, so that's an example of the move. All right, and I tend to like to get my variables on the left. You can get them on the right, it's fine. You could have subtracted 10x from both sides. It would work, okay? Now, we're going to add or subtract the constant. Remember, the constant is the term that doesn't have a variable. Okay, so since our goal is to get x by itself, we want to look at the term that's next to the 2x term, okay, and that's 18. So since it's a plus 18, we're going to do the opposite, which is minus 18. And we're going to do that to both sides of the equation. All right, so 2x is going to be equal to, because 18 minus 18 is 0, so they cancel out, 4 minus 18 is going to be a negative 14. All right, so now we added, or in this case subtracted, the constant, and our final step will be to multiply or divide by the coefficient. Well, the coefficient is 2, so we're actually going to divide both sides by the 2. Our x is equal to negative 7. So there's our answer. Okay, and what's nice about solving equations, you can actually plug that in and do what's called the check step. All right, so the check step works like this. We're going to take that negative 7 and we're going to go back to this original equation and we're going to plug in, instead of 10x, we're going to say 10 times negative 7 plus 18 equals 8 times negative 7 plus 4. All right, so now we're going to use, we've got all numbers, so we're using our order of operations. Negative 70 plus 18, is that going to be equal to negative 56 plus 4? Okay, when I look at this, I get negative 70 plus 18 is negative 52, and that does indeed equal negative 52. So I know that my answer of x equals negative 7 actually works. Okay, so let's look at example number 2. Again, we're going to use that DC MAM. I look at the problem and I can't see any parentheses, so I'm not distributing. But in this case, I can combine my like terms, okay? On the right side of the equation, I have 2x and negative 5x. So I'm going to write this next step as 3x minus 4, and when I combine my like terms, I get negative 3x plus 8, okay? So in this case, I distributed, I combine my like terms. Now, I have two occurrences of the x variable, so I'm going to move the variable, and I'm going to move from the right to the left by doing the opposite. So I'm going to add 3x, and my golden rule of algebra says whatever I do to one side, I have to do to the other. So 3x plus 3x is 6x minus 4 is going to be equal to 8. Okay, and now I'm going to I move the variable. I've got 6x minus 4 equals 8. I want to isolate my variable x, so I'm going to add or subtract the constant. In this case, I'm going to do the opposite. I'm going to add 4 to both sides. And when I do that, I get 6x is equal to 12, because my negative 4 and positive 4 cancel out. My final step is to divide by 6. My x is 2. Okay, again, my check step, I plug in the 2. So I'm going to say 3 times 2 minus 4. Is that equal to 2 times 2 plus 8 minus 5 times 2? Let's see if that works. 6 minus 4, does that equal 4 plus 8 minus 10? So we've got 6 minus 2 is 2, and then we've got 12 minus 10, and indeed 2 equals 2, so that does work. Okay, so I highly recommend doing the check step. for all of the problems that you're doing, especially on a test. But for purposes of time in this video, I'm going to go forward and do the next few examples, okay? But we're not going to be showing the check step per se, okay? All right, looking at number 3, again, I'm going to start with DC mam. So I've got my DC mam. All right, in this case, I can distribute first. So I'm going to start out and I distribute. I've got 2x minus 5x minus 5 equals 3x plus 1. Okay, so I first distributed. I distributed that negative 5 to the x and to the 1, and that's how I got 2x minus 5x minus 5. All right, now I'm going to combine my like terms. So when I combine my like terms, I've got negative 3x minus 5 equals 3x plus 1. Okay, I'm going to move the variable, and I like to keep my variable on the left, so I'm going to subtract my 3x from both sides. So I've got negative 6x minus 5 is equal to 1. I'm going to add or subtract, in this case I'm going to add 5 to both sides, the constant. So negative 6x is equal to 6. And then my final step, I divide by negative 6. So my x is negative 1. And there's my answer. Okay. Let's look at number 4. I'll do number 4 in red. Okay. I'm going to start by distributing. I've got 27 equals 3x. I'm going to take the negative 3 times 6 and get negative 18. And the negative 3 times negative 2x, and I get positive 6x. I'm going to combine my like terms. So 27 is going to be equal to 9x minus 18. Then I'm going to add 18 to both sides. Okay, so I've got 45 is equal to 9x. And then when I divide both sides by 9, I get 5 is equal to x. Notice now my variable's on the right. That's okay, because 5 equals x is the same as x is equal to 5. Okay, so there's my answer. So if at any point in this video, I highly recommend you stopping, pausing, trying a problem, and then see if you get it right. Okay, let's move on to number 5. Okay, again, this is a little off with the lining up. There we go. I'm going to start in this case by distributing twice. Okay, so I get negative 12x minus 9, and then I get plus 24x plus 4, and that's equal to 43. I combine my like terms. So I get 12x minus, and whoops, I can actually combine a negative 9 and a positive 4. So I get 12x minus 5 is 43. Okay, and then I'm going to add 5 to both sides. So 12x is equal to 48. And then I divide both sides by 12. My x is 4. Okay. All right. Number 6, we're going to start by distributing. Okay, we get our negative 20x plus 10 is equal to a negative 6 minus 12x. Okay, so we distributed. We can't combine like terms, but we can move the variable. So I'm going to add my 12x here. All right, when I do that, I get a negative 8x plus 10 is equal to negative 6. Then I'm going to subtract my 10 from both sides. So negative 8x is equal to negative 16. And then I divide by negative 8. My x is equal to 2. Okay, so I know that was a lot, all right, but I want to make sure, okay, to do our check step, we want to verify that we know how to do that. So we take our example, so this example, 4x plus 2 equals 18, all right. In this case, we subtracted 2 from both sides, okay, and we got 4x is equal to 16. We solved, we got x is equal to 4. Again, we plug 4 back into the original equation, okay, so we go back here, and I did it right here, but I'll do it again, okay, so it's 4 times 4 plus 2 equals 18, okay. Now I follow my order of operations to verify that 18 is indeed equal to 18, so we know we got the right answer. Okay, this is important. Your answer is x is equal to 4. Your answer is not 18. That's just used to do the check step. Okay, the other thing that we can do, and this is kind of cool, you can use Desmos. All right, so I'm going to pull up Desmos right now so we can see it. Let me see if I got that there. All right, I'm going to take a quick second, pull it up so you guys can see how to use it. So pull up your Desmos graphing calculator. All right, here it is. Okay, all right, so over here, all right, on the left side, I'll move this over a little bit, see if I can do this. Trying to get this to line up with it. It's not cooperating with me today. There we go, there we go. All right, there's your Desmos graphing calculator. So if I put in the actual problem, 4x plus 2 is equal to 18, notice what happens, okay? Actually, it might help if, okay, so in your graph, if you notice the red line that goes straight up and down is a vertical line. It's actually crossing right at, and you can touch the point, 4, 0. So your x is actually 4. So you can check that way as well. Okay, so, all right, there you go. So you can see an example of that right there. Okay, you can plug it into Desmos, make sure the variable is an x. It only works if the variable is an x. Okay, let's see why my screen won't let me expand it today. All right, so in class we did some whiteboard problems, but what I want you to do is to work on your homework today. So go to 7B and get through the homework problems, and we'll check it with the key tomorrow. Thanks. Bye.